Okay, hi everyone. As promised, this is the video of me showing you how to do some of these combined techniques analysis questions. These are past paper questions from the old spec, but they've got a good range of how they could maybe present them to you. So I'm going to show you how I would do these, and then I've put some up on i6 for you to have a go at. There's a fair few there, but hopefully after you've done them you'll feel a lot more confident with them. So let's have a look at this one. An analytical chemist was provided with a compound J, which is an unbranched carbon skeleton. Now sometimes they will give you hints and tips about what kind of thing you're looking for, so that's important to know. After analysis, the chemist obtained the following results, and you've got 3 pieces of information here that are going to help you. Use this information to suggest all the possible structures for the unbranched compound J. In your answer, you should make clear how your explanation is linked to the evidence. So you're going to have to sometimes maybe even write a sentence in this to explain why you've come to that arrangement. So you've got 3 things here. The thing that I always start with is working out the empirical formula. Okay, so that's the thing I'm going to do first. So you write your 3 columns, write in how much you've got of each one as a percentage in this case, and divide by their relative atomic masses. So 16, 1 and 12. When you put those into a calculator, 70.9 over 12 comes out at 5.8825. That one is obviously going to be 1. And the oxygen comes out at 0.98. And we know we've got to get this into a whole number ratio. If you can't see it very easily, these aren't easy numbers, divide by the smallest, which in this case is the 0.98. That's clearly going to be 1. When you put this one into the calculator, that comes out at 14, and this one is 6. So your empirical formula is C6H14O, and I think you're all happy with that. So that's the first thing I'm going to do, and I've ticked that off to say I've used that information now. Because you need to really, if you can't even get to the end result of getting the actual unbranched carbon skeleton, you'll get points for using all of the information. So even if you can't get to the end because your head's a bit muddled and you've got confused, it's important to use all the info. Okay, so next, I'm going to go for the mass spectrometry. I'm going to do that next. And we know from what we've learned that the molecular ion peak, the very last peak, is the one for the whole structure, and this one comes out at 102. Now you've got an empirical formula here, which is like the simplest way it could be, but as we know, the actual molecular formula could be variants of this. So in order to get to this 102, the first thing you really need to do is try and see what this adds up to, because you never know, this might be this, and so therefore you know that you've got 6 carbons, 14 H's and an O in your structure, and that's it to try and put together. So to do that, we've got to try and get to 102. So we've got 6 lots of 12. We've got 14 ones, and we've got just a 16 to add together. And lo and behold, when you put those together, that comes to 102. So a simple sentence here is useful to say that the molecular formula is the same as empirical formula, therefore the MZ is 102. Right then, last piece of information, the infrared. We know we've got a broad absorption peak at 3350. So you will have your data sheet, so you'll know exactly what this is, but because it's broad, that's a clue. we should know that broad is normally around the OH end, okay? So we know that the 3350 is an OH because it's broad. I would write down all of this evidence. I'd write down all this evidence so that it shows that you understand it all. So that's it. We've used all the info. Now we've got to try and get it into compound J, the unbranched skeleton. Because it's unbranched, we're going to try it in a straight chain. So we'll do 1, 2, 3, 4, 5, 6. And then we know we've got an OH. Now, if you look back at the question a minute, it says suggest all of the possible structures. So that means there's more than one. So we'll start easy, shall we? We'll put the OH at the end of the chain. And then I'm going to be lazy and not put my H's on, but these are all H's. You must put them all on in an exam question. So that's one possible. If we draw it again with the 6 in a chain, the next possible one is with the OH in position 2. And all of these are H's. And then your third possibility is with it in position 3 on carbon 3. Okay, the reason why you don't then go along to that one and that one and that one is because, remember, this would be effectively, if you put it on this side or this side, it could be carbon 1, depending on where you're naming from, carbon 2, carbon 3. So they're the 3 possibilities. So hopefully your answer should look like that. And even if you only know how to do empirical formula, you'll get the marks. Even if you know how to read this off your data sheet, you'll get the marks for that. This bit might have caught some of you out, but try and always make that link between empirical formula and the mass spec value. And then even if you can't get to these at the end, you will get the majority of this 8 marks.